Hi guys, welcome to Learning Electronics Repair. I have two ATX power supplies here. I also have a PCB. This is the 0 to 30 volt, 0 to 10 amp power supply project from PCBWay. We have some of the PCBs here. This is in the shared project section on PCBWay.com. I ordered some PCBs, so from PCBWay, if you order 5 PCBs of this type of PCB, this is double-sided or single-sided, you will pay $5 plus the shipping. The shipping, you have various choices. You can have express shipping for 20-30 euros, or you can have the normal shipping, which takes about 2 weeks. And that's going to cost you about another, well, for here, about €5. So you can get 10 PCBs like this for less than 10 euros, roughly $10, a bit less than £10, okay? So that's what I ordered, and this is what I used to build this project. And here is the built one. At the moment, I'm using one transistor on the output, so this can deliver about 2 amps. But you can put multiple transistors. The original design used 5 of them, and I have plenty of the transistors, so we can add more transistors to this, and that's how we get the 10 amp current load. But for testing, it's a good idea just to put one transistor on the output, and then if something goes horribly wrong, you're just going to blow up maybe one transistor. I have a load connector. This is 2 light bulbs. They're 12 volt light bulbs each, so that will give 24 volts maximum voltage that the lamps can handle. A bit more actually. They'll just glow very brightly and probably not live as long as they normally would, but that's a fine load, up to 24 volts on or so. But obviously the power supply also needs power coming in. Really, this board, if you like, is a regulator, so this allows you to control the output voltage and the output current, but we need, as I say, a source of power. And the cheapest and easiest way to do that is to use ATX power supplies. In the previous installment of this little epic project, it's been going a little while, I showed how to connect 2 ATX power supplies in series to give us 24 volt output to feed into our little project here. But when we tried it, there was a problem. And the problem was that the power supply didn't want to run with the 2 12 volt power supplies. This project is designed to have 2 15 volt windings on a transformer, so the actual control circuitry is powered from 15 volts continuously, and the output transistor either is fed with 15 volts in or 30 volts in. This control board detects the output voltage, and when we get near to the 15, say 13.5 volts or something like that, it then switches this relay and switches in the second power supply. So that's how I have it set up. On my bench power supply, putting 15 volts and 30 volts, it works. On this, putting 12 and 24, it doesn't work. That's how far we got with this last time. So let's take another look, and then let's see if we can figure out why this will not work with the 12 volt supply. Because looking at the data sheet for the chips, that is fine. 12 volts should be absolutely fine to run this as an input voltage. We can see the modifications effectively made to the ATX power supply wiring. So this power supply, effectively, if you look at it, this is the ground and this is the 12 volt output, and it connects to the ground of the other power supply, and that's the other 12 volt output. So this is ground. This point will be 12 volts. So the ground of this one has 12 volts on it, and then the 12 volts out of this will be 12 volts more than ground, which is 24. So that's how we get the 24 volts. I showed you in the original video how we need to modify the power supplies to do this, because we have to isolate the ground on the power supply. Otherwise, if you connect them in a series like this, you will short the power supply out, the output. So we've done all that in the previous episodes, and I will link them into the description of this video. But for those of you who have been watching along, you will also know that I connected the green wire on the ATX connector to ground on both power supplies. Here's the other one. Doing this means that when I power this up, the power supplies will automatically start. So as soon as I apply power, the power supplies turn on. Let's try this again then. So we'll connect our regulator to the output of the two power supplies, and what happened last time, it wouldn't output any voltage. That's the thing. I think we got maybe about 0.3 of a volt coming out of it, regardless of what we did with the voltage and current adjustments. Let's try that again. Here we can see the connections to the input voltage. So the black one here, this is ground, and we connect this to ground on the ATX power supply, the first one. So that is the ground output from this power supply. I'm going to connect this with a crocodile clip lead. We'll use this green one. Okay, so we now have 0 volts ground connected to our regulator board. Now we need to connect the 12 and the 24 volts. You can see here, this is the positive input to the regulator, and this goes to the relay. So on the relay here, we see the yellow. This is the output to this, okay? Normally the relay contact in here is connected from the yellow to the red. That's when this is not powered on. And the red, this is where we put our 12 volts in, okay? When the controller switches this, when it wants more input voltage, it switches from the yellow to the purple. So this is where we put the 24 volts. So let's connect those to our power supplies as well. Here is red then, this is 12 volts, and that connects to the 12 volt output on this power supply, the first one. This is the same one, we're connecting the green crocodile clip to ground, okay? So this is 12 volts. Again, let's just connect it with a crocodile clip lead. There. So we now have the 12 volts connected to the relay. The last one then is the 24 volts, this one. We'll use this yellow crocodile clip lead, and this connects to the 12 volt output on the second power supply. We have a connection here we can use, and this is 24 volts. We connected up to the power supplies then. The next thing we need to do is get our multimeter so we can see what's happening with the voltages, and then we'll try this. We're ready to go. I've clipped my ground lead from the multimeter to ground, so I just need to use one hand for this. We go to the input voltage and switch the power supplies on. Here we should see 12 volts. Okay, we have 12 volts coming in. Output, about 0.15916, yeah? And it's not working. It doesn't matter what I do with the voltage adjustments. I can adjust it, I get a small difference, but I don't get any output from it, okay? And that's the problem. I'll now connect this back up on my bench power supply with plus 15 and plus 30 coming in. And the last time I tried this, it worked, so let's make sure it is still working. And now let's see if we can figure out why it doesn't work with the 12 volt supply coming in. This is a little bit easier to set up the test. We have the bench power supply here, which is a dual supply, and it's set to series mode, so the two power supplies are in series. So this will actually now give me 0 to 60, so it's 0 to 30, 0 to 30, which is total 0 to 60 at 3 amps. The black wire you see coming from here goes to the 0 volt input. The red wire you can see goes to the relay, the red wire coming in. This is your 12 volts. This also powers up the main circuit, the logic if you like, or the control rather. It is analog, this thing. And then the yellow wire is here. This is the 24 volts, but in fact I've set my power supply to 15, so it's not 12 and 24 now. This is giving me 15 and 30. Okay, I've just clipped my ground lead on from the multimeter, so I only have to use one hand again. You can see the light bulbs there. Let's power this up, and you can see the voltage on the power supply as well. We have it powered up. We have just over 15 volts there. And we can now vary the voltage on here and alter the output. So let's see. Yeah. So the power supply is working there. You can see, you can alter the output. And you can see the current is altering on the meter, on the power supply. So that's working. That's high voltage. But for some reason, it doesn't seem to work at 12 volts, at least on my ATX power supply. So let's have a look. So we'll turn this down. We'll put this down to 12. We'll just get it to 12 volts. So I'm now emulating the power supply I have from the ATX. Does this thing still work? And no, it doesn't. Oh, yes, it does, but it's just dim. That's interesting. So on my bench power supply, it is working to some extent, but not on the ATX power supplies. Yeah. What's the maximum voltage I can get out of it? Well, it's not many volts, we can see that. Let's have a look and measure it. Now, obviously the lights are out, the output voltage is 0, okay. And the most I can get out of it is 4. So this doesn't like working on a 12 volt supply. It works fine on a 15 volt supply. So we need to have a look why. Guys, I've had a couple of hours or so looking at this. And Det came in as well. So Det and myself had a look at this. And we can be quite honest now, neither of us can figure out why it doesn't work at 12 volts. Yeah, I can show you what we've seen. This is a bit of a mystery, so let's do this together and then get into the comments. But I will ask, if you're going to get into the comments, do watch the whole thing I'm going to show you now, because if you miss part of this, you'll probably come up with the wrong conclusion anyway. But let's see them, regardless, I guess. Let me just tell you what we found out. This is the chip LM723. This is the voltage regulator. And the first thing we can note with this is that V in minimum, that supply voltage minimum, is 9.5. So 12 volts is more than enough to run this chip, okay? It will run at 9.5. So that isn't the problem. If we look at the data sheet, which is here, you will see pin 6 is a reference voltage, okay? VREF. 4 and 5 are effectively the inputs to an op amp, inverting and non-inverting. 10 is the output, but 9, this VZ, is basically the same as output, but this is to drive an external transistor or transistors to give you more power output, which is what we have. Power in on V pluses on pin 12. That's what we need to know, really. If we look at the schematic here, you can see the LM723 that's varying the voltage. The other one is the current limit, okay? Now, if you have a look, pin 6, this is the reference voltage, which according to the data sheet is about 7.15, 7.15 is the reference voltage. And if you look at this, the reference via this resistor and the potentiometers in series, which you can vary, the 1K fine adjust and the 10K coarse adjust, put a voltage onto pin 5. That's one of the inputs to the op amp, which is built in here. Another input is 4, okay? 4, if we look at it, comes from a resistor divider here, okay? And this is the output. So the circuit samples a proportion of the output voltage, the proportion being dependent on the value of the two resistors. Roughly speaking, this one is 4 times the size of this one, very close to that. So about 1/5 of the voltage that is on output will appear here. If output is, for example, 10 volts, this should be 2 or close to 2, okay? That, as I mentioned, comes in via this 22K resistor into here on pin 4. So what happens is, basically, we have a fixed voltage reference here, which shouldn't change, that puts a voltage on pin 5. The voltage on pin 5 will depend on the position of the potentiometers. And then the circuit will adjust the output via this transistor driving this one and these, so that the proportion of the output that's feeding back into pin 4 equals what's on pin 5. That's how it works. Now let me show you how our circuit is actually behaving. I have my bench power supply set to 12.5 volts. And if we look, we can see the light bulbs are off, okay? There is no output or very little output coming from the voltage regulator here. 0.2 volts, it's very low. I'll just try to put these a little bit closer, we can zoom in a little bit, or I'll show you in a minute. So we have very little output voltage. If I now adjust the potentiometer, this thing, okay, if I adjust this, we can actually cause the light bulbs to light up to a point. Okay, let me just zoom out, you can see it a bit better. There. So now we have 4 volts output. You can see on here it's drawing 0.83 of an amp. If I keep increasing the output, this is like one of these little potentiometers that kind of like clicks as it goes, okay? You can see the light bulb's getting brighter. Output 7.09, 7.15, and then it won't turn up anymore. I'm still adjusting it, but it won't turn up anymore. I'll turn it down, so 705, 717, 7.17. That's as much as it will go. Okay, now let's look at what's happening. So, first of all, we want to look at the reference voltage. Ref is on pin 6. And we can see it as 7.03 volts. In fact, if we look at the ref on the other chip, 7.09. So they're basically the same. And that doesn't change. If I alter the output voltage, say I'm doing the reference, very little change. It might be changing slightly, but not a lot. Yeah, the reference doesn't really change. Let's look at pin 5. So pin 5, this is the voltage set by the potentiometer, is at 2.26. And I said for a 12 volt output, you should have, well, the 10 volt output about 2 volts. So that sounds right. If I turn the potentiometer down, the voltage here drops. The minimum I can get is 1.06. And if I turn it up, the most I can get is 6. Okay. But although I'm turning this up, the brightness of the lamp isn't changing. I'm turning it down now. You can see the lamp. Right, the lamp's changing, yeah? I'll just measure the output voltage and we'll set the point where the output won't increase. 7.29, that's it, okay? So at this point, pin 5 is 2.7, okay? When I turn it up more than that, although the voltage changes, nothing changes on the output. It won't go any more, okay? Pin 4, well, this depends on the output voltage. Okay, and at the point at which the light bulb stops getting any brighter, obviously the output stops going any higher, it won't turn up. Now let me show you what happens if I increase the input voltage. You can see the bulbs there. I'll turn the brightness full up on here, but it won't go any brighter. Now watch. I increase the input voltage. And they go brighter. So changing the input voltage is changing the output. Okay, let me put that to about 12.4. Now I'm going to adjust this to the point at which it won't go any brighter. So on here, you can see there's still the same brightness. Turn it down. Let me get back to it. Output voltage 6.64, 6.9. And it won't go above 6.9. Okay, that is where it will go to. It won't go any higher. Now, if I set it like that, look what happens now if I turn the input voltage up. It doesn't change the brightness of the bulbs. Yeah? Even if I go to like 15, 16 volts, it doesn't change. I can still turn this up now, but I can only do that with an higher input voltage. So something basically is limiting this. It can't go any higher. Look what happens now with a 16 volt input, okay? So we go back to our chip. So pin 6, this is ref, and this should still be 7 volts. And it is 7.02. The reference does not change. Okay, pin 5, which is the output from the potentiometers, is still changing in the same range, up to about 5.9, down to 1.0. So the voltage coming out of our potentiometer varies in exactly the same range, whether we have 12 volts coming in or whether we have 15 or 16 volts coming in. But when we have 15 or 16 volts coming in, the output changes. So we'll see what happens on pin 4. On the other one, it would not go past a certain point, a couple of volts or so. On here, obviously, well, it will now go up to 4.4. Okay, that's the highest we can get on the actual pin 4, the feedback, which is about a fifth of 20. This is giving 20 volts. You'll notice because we have the higher input voltage, the relay is switched. Both sides of the power supply are now on. Yeah, you see current on both of them. That's working properly. It should do that when your output voltage is above a certain point. Okay. So, Jet and myself, we got to this point. Now let's look at the schematic again. Here we are then. So, what have we learned? Well, we know that the reference voltage on pin 6 is the same, 7 volts, regardless of whether the input is 12 or 16. It should be, that makes sense, okay? We know the voltage range we can adjust on pin 5 is the same regardless of the input voltage. Again, that makes sense because the reference is the same and the resistor value is still the same. They haven't changed, they're still the same variable resistors, so that makes sense, and that's what we'd expect. The output on pin 4, or rather input here on pin 4, which is sampling the output voltage, this will go higher to about 4 volts rather than about 2, but that makes sense because the output voltage will go higher. Okay. Let's have a look at what happens on pin 9. So pin 9 is driving our transistors through 2 stages of amplification, basically. Let's see what happens here. And we'll try this with 12 volts input and with 16 volts input, okay? The input now then is 12.5. Right, now let's have a look. So, pin 9 of our chip. This is the output. It's on 1.8. I can turn it down to 0. And I can turn it up to, well, the maximum it will go is to 2.63. Okay, it will not go any higher than that. Even if I continue adjusting it, that is the limit, okay? Let's try this with a higher input voltage. Almost 16 now. Let's have a look. So, on here, pin 9, we have 2.8 now. And now I can adjust it more. So I can adjust the output of the chip higher, up to 4.5. So the question is, why? Why can't I get more drive out of this chip with a lower supply voltage? Well, that might be to do with the fact the lower input voltage supply can give us less output. I'm not really sure. But I've traced this a little bit further. I want to show you what's happening. So now we're on 16 volts. Let's have a look at the base and emitter of the Darlington transistor that drives the output stage, okay? The higher the voltage between the base and emitter, the more drive is going into our output transistor. If I then measure on the base here, I have 30 volts. Okay, 31. As I turn this up, it goes lower, down to about 29.7. So the maximum brightness, that is 29.7. Let's make a note of it. Now let's do the same on the emitter. So emitter voltage, 31.8, okay, 31.81. Again, we'll turn up to full brightness, 30.65. Okay, so I'll make a note of 30.65. Now let me do the same with a 12 volt input. On minimum brightness, the base is now 12.41. I'll set it to the maximum output voltage, which is the maximum brightness. So let's have a look. So we'll turn it up. You can see on the meter, I can't get above 6.9. Okay, that's as much as I can get. 6.99. Okay. What's on the base? 11.2. Okay, so that's down to 11.2. What's on the emitter? 12.34. Okay. Now let's have a look. When has that transistor got the most drive? Has it got the most drive when I'm at full brightness on 16 volt input or on 12.4 volts input? Let's have a look. Well, this is quite simple. So the amount of drive current basically is relative to the difference in voltage between the base and the emitter. Now, first of all, this is a PNP transistor, so the base will be lower than the emitter, okay? And secondly, it is a Darlington transistor, so the voltage across the base emitter won't be about 0.6, it'll be about 1.2, because it's two transistors in series. So what have we got? Well, we can see 30.65 on the emitter, 30.65, okay? Minus 29.7. Okay, 0.95 of a volt difference base emitter, minus 0.95, it's a negative. What about when we're running off 12 volts? Well, let's have a look again. You can see I don't even need the calculator, do I? 12.34 minus 11.2 is 1.14 volts minus. So you can see that when I have a 12 volt input, my circuit is trying to drive the Darlington transistor harder than it is on a 16 volt input. It's trying to drive more current into the base of the output transistor to get more voltage out. Let's have a look at that. Okay, we know, we've just measured it. The drive across here, okay? With the 12 volts supply coming in, the drive is more. There's more base emitter voltage differential. This transistor is more turned on, which is putting more current into the base emitter of the NPN transistor, the output transistor. Yeah? So we should find the same thing here. If we measure base and emitter on the output and we do the same thing, we should find this transistor is being driven harder when I have the lower voltage input. Let's have a look. Well, this is quite easy to do. Easiest way without even using the calculator this time, because it's easy to get to them. We go back to the output. Okay, and we'll turn this up until we can't get any more output. Which is at this point, I can't get any more. That's it. That is the limit. 6.69, okay? What's on the base emitter junction? Well, we could measure and do a subtraction, or we could just stick one of our probes on the emitter and the other one on the base. And we have 0.91 volts, okay, base emitter. As I reduce the output voltage, I'll just turn it down. So we now have 3.5 volts coming out. Let's look at our base emitter. 0.83, it's lower because I'm not driving the transistor as hard, yeah? Let's try the same with a 16 volt input, or 15. That's close. We'll stick with 16, that's what we used before. Close enough, can't be bothered. Doesn't make a difference. Okay, right, so now, I'll turn the output voltage up in a minute, but at the moment we have 3.5 volts coming out, base emitter, 0.75, so less drive. Let me turn the output voltage up to full. Okay, what do we have? 0.992. I'll now adjust the output so I get 0.91 on the base emitter. That's what we saw on the other one at full drive, okay? Just adjust it. Let me just get the, I need 3 hands, but let's try it. .91. What output do I have? 14.15. Okay. So the whole point is that with a 12 volt supply, okay, into this circuit, V plus, which comes from here, okay, with a 12 volt supply, and that's 12 volts or 16 volts, that doesn't double when the relay switches, okay? Because we've checked this with a 16 volt input, the voltage across the base emitter is about 0.95. The thing works properly, we get the full output basically. With the 12 volt input, the drive here is even higher across base emitter, 1.14, but I can't get any more voltage out of here, okay? And this is an emitter follower, so basically the voltage on the emitter is going to be 0.6 volts, whatever the voltage on the base is. We didn't measure the base directly, we measured the base to emitter, so let's just do that now. Okay. Base voltage to ground while the thing switched off, so it's 0. Let me start drawing power. You can see the current going up. So I can get the base up to about 19.4. With a 12 volt supply, I can get the base up to about 6.5. I can't get it above 6.5. So because I can't get the base above 6.5, I can't get the output above about 5.6. You know, that's it. That's just the base emitter voltage drop. It's not possible to get it above that. Although the voltage to the output transistor is switching with the relay, the supply voltage to the circuit isn't really changing. So we can see 12 volts from supply, I have 12 volts input, okay? If I put this up to about 15, 16, where we were before, I have 30 volts input, but that is not the input to my chip. That's not V plus. V plus is 15. Well, V plus is 15, you can see it there. So with 3 volts more supply on this chip, even though this chip works at 9.5 volts, I can get the output transistor to give the full output voltage. With 12 volts on this chip, I can't. Yeah. 11.7, okay, it's close to 12. I don't think the problem with this has anything to do with the chip. I thought it was to do with the value of resistors, so I've tried a few things. You see a bit of messy soldering around here. I'll show you what I've tried, but none of this helped. I know the voltage on pin 5 here is varying with the potentiometers within the same range, regardless if I have a 12 volt or a 15 volt supply. But I have tried shorting this resistor or putting a low value resistor across it. If you look at a lot of schematics, ref goes directly to the potentiometer, another end goes to ground, it doesn't have these resistors in. I thought, well, let's try it anyway, just to see if one of these is limiting the amount of voltage I can set, but I didn't expect it to make any difference, as the voltage range on pin 5 is varying as it should, and it didn't make any difference. My next thought was that the chip cannot drive this transistor hard enough with a lower supply voltage. So I tried putting a 10k resistor across here, which gives me about 3k3 or 3k7 in total with the 2 in parallel. It made absolutely no difference, that didn't help. I then thought maybe this transistor can't drive this one hard enough. This is prior to me making the measurements, and you can see full well it's actually driving it harder when I have a 12 volt supply. But I tried again putting another resistor across here to give me about 2k, and it didn't make any difference at all. Det and myself had quite a discussion about R31. This effectively is the base emitter resistor for this transistor. Now, as I was saying with Detlef, if we want more drive into the base, we effectively want more current flowing this way. we actually have to increase this resistor value a little bit, not decrease it. If we decrease that value, we'd actually end up with less voltage here, less current drive. So we tried putting a 3 ohm resistor in series with that gauge up to 21, and it didn't help. It still didn't solve the problem. The point is, for whatever reason, with a 12 volt supply here, this transistor cannot drive this base to high enough voltage to get the correct output. Simple as that. Why, I don't know, because it appears to be working harder, hence the higher base emitter voltage, to try to get the voltage here high enough to get the correct output voltage. It's like it's saturating, it's going as far as it can and still can't raise the voltage here. So guys, there's the mystery. Why does it work with a 15 volt supply and it doesn't work with a 12 volt supply? So, do you like mysteries? I love them, but I also like people to help me sometimes and say, Rich, it's this or it's that, yeah. So guys, comments please. Anything you suggest that we haven't already tried, we'll try it again on video. You can see the results. Can somebody explain why the circuit doesn't work with the 12 volt supply, and can it be modified to do so? I'm sure it could be modified to do so. It's just my attempts so far haven't done that. Okay, well, that was a failure from me, but hopefully not a failure from you guys. So I look forward to hearing from you soon. I also look forward to doing the next part of this video, trying out your ideas. Let's do it in about a week or something from now, yeah? And then let's see if we can get this to work. No prizes for the one who figures it out, but a hell of a lot of kudos. See you all soon again then on Learning Electronics Repair. Ciao for now, guys.